Hello, in this math video, I will do a real GED, a real practice GED math exam, and maybe I'll split this in two videos. Let's see what happens. Okay, so this is a real GED math practice exam, and in the real GED math exam, there will be you don't need to you don't need to memorize any formulas. They give you all the formulas you need, so there's no need to memorize it. Um, and then they'll tell you when you can or cannot use a calculator, and you'll see what I mean. So I'll show you. So let's start with the GED Math Exam 1. Okay, so this is time, but I'm not gonna go as fast. I'm not gonna be quick. I'm gonna take my time because this is a practice exam. Okay, so as you can see, the exam, and then they have the materials. Basically gives you all the formulas, so there's no need to memorize or cheat. Okay, let's start with question one. So question one says, determine the common revenue generated by a charity run, a silent auction, and a concert considering the charity run raised 1,200. The charity raised 1,200, the silent auction collected 950, and the concert earned 1,850. And it said no calculators allowed. So this is not as bad as it looks. You just need to figure out, they want to know the revenue, so you just have to add up everything. And the good news is, yeah, revenue. Ugh, I don't like this color. Let's use blue. I don't like blue. Do you like blue? Uh, it's fine. So the revenue is just adding up all the charities. So one of them, the charity ran 1,200, and then the silent auction 950, and then the concert raised 1,850. Okay. So all you got to do, the good news is there's no decimals, so you don't have to line up the decimals like the other one. You just put the larger one on the top, or the one with the most significant on the top, right? Let's see. You could either put 1,200 or 1,850. They both have, yeah, I would put 1,850. I guess I would put the larger one on the top. So 1,850 on the top, and the next larger one is 1,200. And then the smaller one is 950. You do have to line it. You do have to kind of line it. Put the nine above the two. So when I say aligned it, I mean aligned to the right. So, and then just add them up vertically. So we'll start with the further right with 0 plus 0 plus 0, 0. What's 5 plus 5? 10. Carry the 1. So what's 9 plus 2 plus 8 plus this 1? Let's see, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 0, carry the 2. And then what's 1 plus 2 plus 2? That's 4. So it is a total revenue of D 4,000. Right? Not too bad. You can do this, right? Okay, question two, I'm going to clear. Question two says the population of CDP is 780,000 and the population CDQ is 450,000. Determine the difference in populations between CDP and CDQ. So when they say the difference, I automatically know it relates to subtraction, right? So they're saying that determine the difference in population CDP and Q. So basically they're saying whatever population P is, subtract that from population Q. That's it. So population P has a total of 780,000 minus the population of Q is 450,000. Okay. So there's no decimals involved. So I would put the larger value. So I would put 780 on the top. You see this comma? That's a comma. You don't have to put that comma if you don't want to. Just make sure you have the correct amount of zeros. One, two, three, four. There should be four zeros. Good. Minus, and then you see this comma here. You don't need to. Just make sure you have the right amount of zeros. One, two, three, four. It would be 4, 5, 1, 2, 3, 4. Okay, subtraction, and then so start on the right hand. So the good news is they're all zeros on the right. So what's 0 minus 0? 0. What's 0 minus 0 is 0. 0 minus 0, 0 minus 0. And then 8 minus 5. You don't have to borrow. The number on the top is larger than the one on the bottom, so you don't have to borrow. That's how you know you borrow. So what is 8 minus 5? 3. Since we didn't borrow, we don't have to make the 7 to a 6, right? So on 8, so this is very important. 8 and 5, you didn't borrow because this one is larger than the one on the top, right? If it was 0 and 5, you would have to borrow. This would be like a 10, and then 10 minus 5 is 9, and then you would have to make the 7 to a 6, right? So that's only if the number on the bottom is larger than the top, then you would have to borrow. But if it's the number on the top larger than the bottom, you don't have to borrow. So 7 minus 4 is 3. And that is your final answer. So it would be, I guess, 330,000. So that would be letter A. Right, let me double check my zeros. So it's either A or B. 1, 2, 3, 4. Yes, it's letter A because it has 4 zeros. 1, 2, 3, 4. Perfect. Question 3. A factory produces 45 electronic devices per assembly line, and there are 124 assembly lines in the manufacturing facility. How many electronic devices does the factory produce in total? Whoops. Okay. Number 3. So what you got to do is first figure out an equation. So there's no calculators allowed, so don't even think about it. Yes, what equation are we going to use? So I think we're going to have to use the linear equation. So the linear equation is y equals mx plus b, right? If you need a refresher on linear equation or linear lines or graphing, anything about linear or anything related to linear, you can check out the supplementary video on linear section. Okay, so we know we're going to use this equation. And do we have our m and our b? So remember, m is the slope and b is the starting point. Your starting point, or your, what is it in revenue? It would be like your initial cost. So this is how you know you have a slope. It's an uncontrolled value, right? Or an uncontrolled cost. Do we have anything that's uncertain? Or it says factory produces 45 electronic devices per assembly line. That's the big clue. This is your M. 45 is your M. Because it's uncontrolled, because we don't know how much assembly line we're going to create, right? So that's how I know my M is 45. And then do we have our B? No. The B doesn't have any. Usually you don't have, sometimes you have a B, sometimes you don't. We don't have a B, so our B is going to be 0. So our equation is going to be y equals 45x. And then you don't have to put the B for 0. Okay, then what you're going to do is figure out your variables. So what is my x and what is my y? So I think our x, or I know my x is going to be assembly line. So yes, my x is assembly line. And my y, I believe it's going to be the cost. I mean, not cost. Um, no, it would be the electronic devices. So number of electronic devices. Okay. So do we have an X and do we have a Y? Or so we know our X is assembly line, our Y is electronic device. Do we have any of them? Yes, they say specifically there are 124 assembly lines, so that my X is 124. Do we know what our Y is? No, that's what we got to find. That is what we're going to find out. So all we're going to do, the next step is, because they want to know how many electronic devices, we're just going to replace this X with 124. So it's going to be 45 times 124. Now they specifically said no calculators. So we'll have to do this by hand. So how do I multiply 45 by 124? So you could do it this way. You put the larger number on the top, so 124 is larger, and then put the smaller number on the bottom, make sure it's completely aligned to the right. So aligned to the right, and then horizontal, and then just do your multiplication. What is 5 times 4? 20. Carry the 2. What's 5 plus 2? What's 5 times 2 plus 2? Well, 5 times 2 is 10. Carry the 2. That's 12. Carry the 1. What's 5 times 1 plus 1? That's 6. And then a placeholder. And then what's 4 times 4? 16. Carry the 1. What's 4 times 2 plus 1? 4 times 2 is 8, plus 1 is 9. And then what's 4 times 1? 4. I'll add them up. So 0 plus 0, 6 plus 2 is 8, 9 plus 6 is 10, 11, 12, 13, 14, 15. Carry the 1. And that's your answer. C. 5,580 electronic devices are produced when there are 124 assembly lines. Okay, good. Okay, question 4. Which of the following is equivalent to negative 7560 divided by 15? So we can't use a calculator, but we can. Oops. So we can't use a calculator, but we can just do this by hand. So how do we do this? So first off, what is our final answer? Will it be a positive and negative? I mean, will it be a positive or negative? Well, what happens when you divide a negative divided by a positive, right? Negative 7560 is negative and 15 is positive. The rule states if you divide a negative divided by a positive, it comes out negative. So you can forget about A, you can forget about C, and that's it. So it's either B or D. Then what we're going to do is do the box method. And then this number here always goes inside the box. So you could put negative 7560. Or you don't really have to put the negative because we said our final answer will be negative. So you don't really have to put that minus if you don't want to. And then this one is always outside. Okay, so how do we do this? So let's start. I know if, let's start with the 75. Does 15 go to 75? If so, how much? Yes, 15 goes into 75, exactly 5. So I'm going to put a 5 and I'm going to put that 5 above this 5, right? Do not put it above the 7 because we want it the 75. So what's 15 times 5? Exactly 75. Bring down the 6. And then how many times does 15 go into 6? It's too large, so you're going to put a 0, right? 15 is way too large for 6, so you're going to put a 0. And then bring down this bring down the 0. And then how many times does 15 go into 60? 4 times. So what's 15 times 4? 60. No remainders. So your final answer is negative because the negative divided by positive is negative 504. Letter D. Okay, the next one. So no characters allowed on this one. And it says, which of the following lists from smallest to greatest? So smallest to greatest. So we have to put in from smallest to greatest. So uh yeah, I know it's a pain, but if some of these fractions you know as a percentage, um some of you will probably know that off by hand that um 5/8 is the largest, and then 1/2 might be the smallest. Some people can see it. So I know 1/2 is the smallest because 1/2 as a percentage would be 50, or as a decimal would be 0.5, right? If you put one here, two, and then decimal. So that, yeah. So 1/2 is 0.5. So if you want, you could put above 1/2 is 0.5. And then 3/4 is, if you do the box, 3/4, like I've heard that so many times, like 3/4 of the population died. That means that's more than 50%. I think it's like 75%. But this is how you know if you didn't know. So do the box. The numerator goes inside the box, so three inside, and then four goes outside. And you obviously know that four is way too large for three, so you're going to put a decimal, bring down an invisible zero. Then how many times does four go into 30? And then make sure you line the decimal about seven. So you put the seven above the zero. Seven times four is 28. And then 30 minus 28 is two. And then bring down the invisible zero, that is five. So this is going to be 0.75. Right? That's very close to one. So it would be, here, let me write this up, 0.5 for the 1/2, 0.75 for the 3/4. And then what about 1/24? That's fairly small. I know 1/24 is very small. It's probably the smallest. Yeah, I think it's the smallest, but if you're not sure, let's convert that to a decimal. So 1/24 as a decimal. So you do the box, one goes inside and 24 goes outside. Obviously, 24 is larger than one, so you could put a placeholder, I mean decimal, and then yeah, that's 24. This is still to put, line it up. 24 is way too big for 10, so you're gonna have to add an extra zero. Now that's 100. So how many times? So if you want, you could put a zero here, and then 24 is too large for 10, so you could put another zero here. And then how many times does 24 go into 100? About four times, right? 24 times 4, 16. 4 times 2 is 8. That's 96. 100 minus 96 is 40. And then how many times does 24 go into 40 once? You can stop there, right? You don't have to keep on going. It's just simple. Yeah. So it's going to be 0.041. So that's 1/24, and then 5/12. So if you could do the box, that's fine. So put 5 in the box, 12 outside, placeholder of 0. How many times does 12 go into 50? About 4, right? 12 times 4 is 50 minus 48 is 2. Bring down the 0. How many times does 12 goes into 20? At least once. And then 20 minus 12 is 8. Bring down the 0. And then how many times does 12 go into 80? About 6. So 5/12 will be 0.416. And then the last one's 5/8. So if you don't know what 5/8 is, that's probably the largest, right? So 5 here, 8 here, placeholder is 0. And then how many times does 8 go into 50? About 6. So put the 6 here, and then 8 times 6 is 48. Bring down the 0. How many times did 8 go into 20? Twice. 20 minus 16 is 4. Bring down the 0. How many times does 40 go into 8? 5. So it'd be 0.625. Okay, so now we got to put it in order. So smallest to largest. So which one is the smallest? The 0.041, so that would be 124. The next smallest one is 0.416, so that would be 5/12. The next larger one would be 0.5, so that would be 1/2. And then the next one would be 5/8, which is 0.625, right? So 5/8. And then the next one would be, the largest one would be 3/4. Okay. So which one will that be? 124, 5/12, 1/2, 5/8, 3/4. 124, 5/12, 1/2, 5/8, and 3/4. Letter A. Okay, so that's how you do it without a calculator. Okay, question 6. Tom and Sarah are reading a book, are reading books. So Tom and Sarah are reading books. Tom can finish the book in 5 hours, while Sarah can finish the book in 8 hours. If they both start reading at the same time, how many hours will it take until they finish reading their books at the same time? So this is just a LCM problem, lowest common multiple problem. That's it. So all you got to do is find the least common multiple of their individual reading time. So let's see. Tom can read in 5 hours. And Sarah can read in 8 hours. So all you got to do is make a factor tree. So let's start with 5 or Tom. What are the factors of 5? 1 and 5. And then you circle a prime numbers. What are the factors are 8? So make a factor tree of 8. So what two numbers multiply 8? Maybe 2 and 4. 2 is prime, 4 is not. It could be broken down as 2 and 2. And then you have a prime numbers are 2 and 2 or 2 cubed. And then with the factor tree, what you do is you look at your prime numbers, right? Our prime numbers are 1, 5, and 2, or 2 cubed. And if you have a repeating base of your prime numbers, pick the one with highest power. So none of these are repeating. You have a base of 1, 5, and 2. So when they're non-repeating, just put it all together. So it'd be 1, 5, and 2 cubed. And when you put it all together, 2 cubed is 8, times 5 is 40, times 1 is, that's 40. So it's going to be D. Okay. Question 7. I don't know if you could see this. It's kind of small. It says simplify the expression of A10 B fourth all over A7 B second using rules of exponents. So if you want, I can write it again. So it is A10 B4 over A7 B2. So there's just, you just got to remember the exponent rules. So one of the rules was when you multiply, with when you multiply exponent with the same base, add the exponents, or add the exponents. And then what else are we doing? We are also doing division. So when you divide, you subtract. Okay. So yeah, go ahead and do that. When you divide, when you multiply exponent with the same base, you add the exponents, and when you divide exponent with the same base, you subtract. So what I would do is before I divide, I always check. Let's look at the numerator. Before I divide, I know it's tempting just to divide, but check in the numerator if you can combine like terms. So can you simplify A10 times B fourth? No. Reason why you can't simplify this is because they have different base. This is a base of 8. This is a base of B. Now do the same thing with the bottom. Can you simplify A7 and B squared? No, because they're different bases. So then what we'll have to do is just divide. So let's start with the letter A. What is A10 divided by A7? So we said that when you're dividing with the same exponents, you subtract. So it's going to be 10 minus 7, which is, what's 10 minus 7? 3. Now do the same thing with the B's. What is B4 divided by B2? You are dividing, so you're subtracting. So what is 4 minus 2? 2. And that is your final answer. So it's A cubed B squared, and that is letter D. Okay, good. Okay, question 8. Which of the following shows how many four-digit numbers are created by using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Okay. Yeah, so and then it says repetition is allowed. So we have a four-digit pot. So let's write out a four-digit. 1, 2, 3, 4. So between 0 and 9, how many numbers are there? So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers? So for how many ones places are there? There's a total of, so there would be a total of nine just for the ones, right? For the single digits, right? Right, single digits. So, yeah. And then what about for the second digit, for the second place? So, yeah, so there's a total you could do. So second place, like remember there's a four digit, so you could do one, two, one, three, four, five, yeah. And then don't forget zero, include the zero. So there's a total of 10. And then you said there's repetition, so this could be 10 and then this could be 10. So when you multiply it out, you have nine for the one, so nine, and then 10 times this 10 times this 10, and you get 9,000. Okay, so that is letter B. Okay, question nine. Question nine says evaluate the expression. So you have to do when you're dealing with orders, you're going to most likely do some called pendes, right? Use this when you do order of operation. So let's start with this. So let's start with the parentheses. Do we have parentheses? Yes, we have two parentheses. You see one right here and right here. Let's do those first. And the good news about these parentheses, there's only one order of operation. So this one says you can use a calculator for this problem. So I'm going to use a calculator. Um, so in this parentheses, you have one order of operation, which is subtraction. So you don't have to do pendes all over again. If you have more than one order of operation and you inside the parentheses, you would have to do pendes all over again for that parentheses, if that makes sense. But because over here there's only one order of operation in this parentheses, you could just do subtraction. So what is 5.2 times, 5.2 minus 2.8? It's 20.4, 2.4, right? And then bring down what you haven't done. So I haven't done this times three, so you don't have to put this x. You could put it just right adjacent to it if you want. Plus, and then for the same thing here, this is an x means multiplication. You don't have to put that x. You could just put it right next to the parentheses because that means the same thing as multiplication, right? So when something is squished, that means multiplication. So now what I'm going to do is do this parentheses because according to order of operation, I've got to do that parentheses. And the good news is there's only one order of operation is subtraction. What is 9 minus 3.6? It is exactly 5.4. Okay, now we did the parentheses. Now, see, so I did the parentheses and bring down what I haven't done. Then do the next one. Do we have an exponent? No. Do we have a multiplication? Yes, we have two multiplication. Let's do that. So what's 3/4 times 2.4? So you could just put that in the calculator. 3 times 2.4 divided by 4, or 3/4 times 2.4 in your calculator. That gives me exactly 1.8 plus. And then what's 2/3 times 5.4? So you could put that in the calculator. I get 3.6. And then we don't have a division. We have an addition. That's our last order of operation. So what's 1.8 plus 3.6? It's 5.4. So which one of these is 5.4? Well, obviously not A, obviously not B, obviously not D. And now they use a fraction. So because I use a calculator, you did you know is 2/5 is the same thing as 0.4? So 5.4 is exactly the same thing as 5 and 2/5 as a mix. Okay, so this is an order of operation. Let's do the next one. Consider this rational function. What is the simplified form of this expression? So we have 2x over x squared minus 4 plus x plus 2 over 3 times. Do you see this x? It means multiplication. 2x over x squared minus 4. So what I'm going to do is maybe rewrite it again. I don't know. It makes it easier. So instead of this x, I'm going to just write it as two parentheses. So x plus 2 over 3 times 2x over x squared minus 4. Okay. So that's all I did. Instead of this x, I just put it right next to each other, squished together, because that means multiplication. What I would do first is simplify this thing right here. I don't know why, but I think it's much easier. So I'm going to simplify this. So do you see anything you can do here? Well, remember when you're multiplying fractions, you multiply across. But before I do that, is there anything I could break down? Yes. Do you see this x squared minus 4? That's a perfect square, and that could be broken down. Oops. That's a perfect square, and that could be factored out as x plus 2 times x minus 2. Okay. So I'm going to rewrite this as x plus 2 over 3 times 2x over x plus 2 times x minus 2. Okay. And then what you could do, this is why I did this, because I want something canceled. What do you see that's the same? That's the same top and bottom? Yes, that's plus 2. So on the top, you're left with 2x, and then on the bottom, you're left with 3 and x minus 2. Plus, and then over here, you're left with 2x over x squared minus 4. Let's break that down. We know that is an factored out as x plus 2 times x minus 2. Okay. Now we are adding fractions. So what do you need when you add a fraction or subtract? You need a common denominator, LCD, common denominator. So if you forgot how to find the common denominator, there is a video how to finding LCD in the supplementary video. So if you need a refresher, but this is basically how you do it. So you look at the bottom, make sure it's in the most primest form, which it is, right? On the bottom, you can't break it down. And then you look at the bases. If you have a repeating base, pick the one with the highest power. If you have a non-repeating base, just bring it down. So what would be my LCD? My LCD is going to be, so x plus 2, don't think of it as two terms, think of it as one base, or x plus 2 to the power 1, right? So this is one base. So I see a repeating, and anywhere on the bottom? No. So bring that down. What about x minus 2? Do you see it anywhere else on the bottom? Yes, I see it right here. But because they're both to the power 1, it's going to be x minus 2 to the power 1. Okay, what about this 3 here? I don't see it anywhere else on the bottom, so bring it down. That is my LCD. Do not FOIL it out yet. Yeah, don't FOIL it out yet. So on the bottom, you could just put your LCD. So on the bottom, you could put 3 parentheses x plus 2 times x minus. And you see, this is the reason why I don't FOIL out, because there's a good chance that something might cancel. So on the top, this is where you're going to do some algebra. So on this side, right here, 2x over 3 times x minus 2. What are we missing to get our LCD? Well, we have the 3 and we have the x minus 2, but we are missing the x plus 2. So you're going to multiply top and bottom by x plus 2. And then on the left side, over here, we have a bottom of x plus 2 and x minus 2. What are we missing to find our LCD? Well, we have the x plus 2 and the x minus 2, but we're missing the 3. So you're going to multiply top and bottom by 3. So on the bottom is always your LCD. So this is where you're going to put on the bottom. And then on the top, you're going to do some algebra. So on here, what's 3 times 2x? 6x. Over here, so you put 6x. And then over here, you're going to do some foiling. So what's 2x times x? 2x squared. What's 2x times 2? 4x. And then I guess you can put in order or clean it up. So you have 2x squared on the top, and then you can combine 6x with 4x, which is 6, 7, 8, 9, 10x. And then on the bottom, it's just your LCD. Hey, I don't see my answer. So you're gonna do a look. This is why you're gonna have to do a little bit more simplification. So actually, there's nothing more you could do on the numerator. So I do see, I think our answer is A. So what I think they did was, so 2x squared plus, did you know that 2x squared plus 10x can be arranged? They didn't put it in descending order. It's also the same thing as 10x plus 2x squared. And then on the bottom is, why isn't our bottom 3 parentheses x plus 2, x minus 2? Yes. They just cleaned it up. So what's, they factored it or foiled it. So what's x plus 2 times x minus 2? It's a perfect square, so it's going to be x squared minus 4. And then FOIL out this 3, so it's going to be 3x squared and then negative 12. Okay. So as you can see, that is why my answer is letter A. Okay, next. So yeah, that was a lot. But yeah, let's move on to the next one. So question 11. So question 11 is a word problem. It says Lisa is currently planning a road trip from one city to another. On her map, 4 centimeters represents 60 kilometers. She measures the distance between the two cities on the map and finds it to be 20 centimeters. How many kilometers are apart are the two cities? So this is not a linear equation problem. It's called a proportional word problem. And I like these problems because they're very proportional word problem. I like these problems because they're easy to set up. So you've probably seen proportional maybe in your dosage calculation if you're a nursing student, but this is how you set it up. You can set it up any way you like. It's just so you set it up like this as two fraction, and then what are our units? So one of our units they talked about centimeters, and the other unit they talked about kilometers. So what I mean is you could put centimeters on here and kilometers on the bottom. But if you do that over here, this should be centimeters and then kilometers. Okay. You can also do it vice versa. You could put kilometers on the top, centimeters on the bottom. But that means you would have to put kilometers here and centimeters on the bottom. Okay. Really up to you. I'm just going to put centimeters on top, kilometers on the bottom. And then just fill in our blank. So you should have one unknown. if you have two unknowns, you probably did it wrong or we can't use this method. So what do we have? So on her map, 4 centimeters represents 60 kilometers. So 4 centimeters represents 60 kilometers. And then what other information? She measures distance between the two cities on her map and finds it to be 20 centimeters. So put 20 centimeters. How many kilometers? So that is our unknown. So we're going to put an X here. Okay. Now go ahead and cross multiply to find your X. So 4 times X is 4X. And then it's going to be 20 times 60. That's 4X. And then what's 20 times 60? 1200. And then you're going to divide this by 4. Divide this by 4. You get 1200 divided by 4, which is 300. So that is letter B. Okay, so that is how you set up this proportional word problem. Question 2, 12. Kim purchased a cloth with a width of 75 centimeters. Calculate the length of the cloth required to make 20 handkerchief. If each handkerchief requires a piece of cloth that measures 25 centimeters by 15 centimeters. So yeah, so this one you might have to draw a little bit of a picture. Imagine a cloth like this, like a cloth, like a rectangular cloth, right? And here's your length, and then here's your width. So they specifically said the width is 75 centimeters, and we don't know what the length is. But they also tell us that inside this cloth, it's going to be made up of smaller handkerchief. And this handkerchief is not a square, it's a rectangle. And it's 25 by 15 centimeters. So imagine this handkerchief inside this cloth, right? We want to know how much handkerchief can we make inside this cloth. So what you need to know is you need to know some formula. So the area of a rectangle, so the area of a rectangle is length times width. And then let's find the area of the handkerchief. So the handkerchief is the area of the handkerchief, so it's length times width, or length is 25 by 15. So that area is 375 centimeters squared. Okay, then what we're going to do is take the area of the 20 handkerchief. So there's 20, oh, okay, so there's exactly 20, 20. So the area of 20 handkerchiefs, so one area of one single handkerchief is 375. But how much is there for 20? So 375 times 20, which is 7,500. Then what we're going to do is use that information and plug it here. So we can replace this area with 7,500, right? Because that's the area of the cloth, of the 20 cloth. So 7,500. And then we don't know what our length is. That's what we want to find, right? We want to find the length. So we don't know. We'll just call it X. And then times it by the width. Do we know the width of the bigger cloth? Yes, it's 75. Okay, now it's easy. Now you want to solve for L because we want to isolate L. So how do I isolate L? So I have to get rid of 75. How do I get rid of this 75? Do not subtract 75. This is multiplication, so do the opposite. So you're going to divide both sides by 75. So what happens is this cancels, and then you're left with L equals, what is 7,500 divided by 75? That is 100. So the length of this larger cloth is 100 centimeters. B. Okay. 13. In a right triangle XYZ, YZ, the length YZ is the hypotenuse. The length of side XZ is 3 centimeters, and the side XY is 3 times the length of XZ. Find the length of YZ. Okay, so you're gonna have to draw an image and you have to draw it correctly. Otherwise, it will be wrong. So imagine we have a right triangle like this. Put this little box symbol to represent right triangle. And then they said that the length, they are specifically saying that the hypotenuse, YZ is the hypotenuse. So you could put Y here and Z here. And then I guess you have no choice to put X here, right? Because it is XYZ triangle. So they say that the YZ is the hypotenuse. And what else? They said that the length of side XZ right here is 3 centimeters. And the side XY, so this side here, XY, is 3 times length of XZ. So 3 times XZ, which is 3. So 3 times 3 is 9. So this length here, Y is X or XY is 9. What we got to do is find the hypotenuse. So we have 2 legs and we got to find the hypotenuse. So we're going to use a formula, and the formula we're going to use is called the Pythagorean theorem. Okay, so this only works for a right triangle and when you have 2 known side lengths. So what is the Pythagorean theorem? It states a squared plus b squared equals c squared. So a and b represents leg and c represents the hypotenuse. So one of my legs was 30. So it's 30 squared. And then one of my other leg is 9. So it's 9 squared equals the hypotenuse. I don't know what the hypotenuse is, c squared. So what's, whoops, did I say 30? Sorry, it should be 30. So it's 3 square, not 30 square. What's 3 square? 9. What's 9 square? 81. What's 9 plus 81? 90 equals c squared. And then you want to solve for c, so you're going to take the square root. So c is square root of 90. Now you don't see our answer. It's not D, it's not C, and it's not A. Now they simplified this. So how, I know square root of 90 is not a perfect square. So you can either put square root 90 in the calculator. If you put that, that's about 9 point, in decimal, it'd be like 9.48. But you could tell, like if you put 3 radical 10 in the calculator, that should be 9.48. So if you're in a jam and you're really in a rush and you can use a calculator, put this and you'll see that this is it. Now, if you have some time to spare, if you want to simplify this, this is how you do it. So what 2 numbers multiply 90? So you're going to make a factor. What 2 numbers multiply 90? It would be like 10 and 9. And 9 can be broken down as 3 and 3. And then do the same thing with 10. What 2 numbers multiply 10? 5 and 2. And then 5 and 2 are primes to circle it. And then what you do is look at this number here. There's no number. That means there is. It's just an invisible 2. What that 2 means is you circle pairs of 2 of your prime numbers. So what I mean is this 3 and 3 is a pair. So that becomes 3 when you put it outside. And then inside is your leftover prime numbers. So our leftover prime numbers are 5 and 2. So that's 3. And then 5 times 2 is 10. So it's B. Okay. Okay, so that is letter B. Let's move on. Okay, let's do question 14. So question 14 says, consider the table. What should be the value of K? So you have a table or coordinates. What should be the value of K so the table shows a proportional relationship? So proportional means they have the same slope. So yeah, proportional just means so what you're going to do is we're going to use the slope formula. M equals y2 minus y1. And then what we're going to do is step two is we're going to use this formula. And step two is we're going to find the slope of two random points. So it could be any points as long as they're two exact points. So use any points you like. So if I use, for example, if I use -3 comma 6 and -4 comma 12. So I'm going to label this x1, y1, x2, y2, right? And then just put in the formula. So this is why I label it so I don't get confused. So what's my y2? 12 minus my y1 is 6. My x2 is -4 minus my x1 is -3. So what is 12 minus 6? 6. And then on the bottom, two negatives becomes a positive. So what's -4 plus 3? -1. And what's 6 divided by -1? -6. Okay, so I know my slope is -6. And then the third step is, let me write this down. Use the slope formula again and pick the points. So now I'm going to do is pick another point or to another point, but I'm also going to pick this point with the K because you want to solve for K. So I'm going to use the point -1, -6. You don't have to use -1, -6. You can use any other point. And then I'm going to use, I have to use the point -2, comma K, because that's my goal. I got to solve for that K value. And then I'm going to label this x1, y1, x2, y2. And then you're going to use the M formula, slope formula. So M is y2 minus y1 over x2 minus x1. Okay, so this time, do you see this M? I'm going to replace that M. We said that slope is proportional, so it has to be the same slope. So we're going to replace that M with -6. And then I'm going to replace my y2 with K minus my y1, which is -6. And then x2 is -2 minus my x1, which is -1. So it's -6 equals two negatives becomes a positive. And then over here, two negatives becomes a positive. So -2 plus 1 is -1. And then go ahead and cross multiply. -6 times -1 is +6. And then you have k plus 6. And then subtract 6 from both sides. So my k value has to be 0. So my k value has to be 0 in order to have a slope of -6. So it's going to be C. Okay, so that was a kind of lot to go over. So I'm Okay, let's move on. So question 15. So yeah, a cylindrical water tank has a height of 6 feet and a base radius of 4 feet. On the top of this tank, there is a conical roof with a height of 5 feet. What is the total volume of the tank and the roof combined? So, and then they specifically said replace pi with 3.14. So there are some formulas we got to know. We got to find the volume formula, volume of a cone. So they do provide you. You just have to figure out uh, which one is the volume of the cone. So uh, step one, find the cylindrical cone. Let me see if I want to change my writing tab. Then does not work. You know what? I'm gonna stop here. I will do a. I'm gonna because I after an hour my XP tablet kind of like fades out. So I'm gonna stop here and do a part two.